So now we're going to ask the question, what happens when we don't know the interest rate? So here's Candace. She wants to invest $30,000 today. She needs $150 in 21 years. What interest rate does she have to earn? So when we go through our questions here, we say, do we need to know the present or the future? Well, in this case, we know both, okay? Single sum or an annuity, we're dealing with a single sum. And what are the number of periods? Well, it's the 21 years. And what's the annual interest rate? Well, that's what we're looking for. So when you're setting these up, you can set them up using either the present value or the future value tables, whichever makes more sense to you. But it's all in keeping in mind what you're trying to accomplish and just setting up the problem. So let's look at using the present value method. You might say, okay, so we've got 30,000 today, and that's going to be equal to 150,000 in the future times the present value factor of 21 periods and an unknown interest rate. So that's how you set up the problem. And then you kind of work it like you would any math. You want to find out this right here, just lump that all together, just you could call that X if you wanted. So you're going to take the 30,000 divided by the 150, and that will give you that factor. Okay, so let's do that. So you go 30,000 divided by the 150,000. Whoops, that's too many. It's still too many. 150 by 150. Okay, that worked. And so when we divide that out, you go to the 30,000 divided by the 150, and you don't really get 0. You just have to get a factor. Okay, so you get a factor of 0.2. So now what you want to do is you're going to go to since we're using the present value, you're going to go to the present value single sum table, and you're going to go to 21 years on that table. So you'll go down to 21, and then you go across until you get the factor closest to 2. And the factor closest to 2 will tell you that the interest rate is 8%. Okay, so when you're working this out, you can say, use your 30,000 equals the present value factor of 21 periods. You don't know the interest rate. Divide it out, you get the present value factor of 2. Okay? And so that's how you do that. Now the other way to do it is you can set it up as a future value. And really this is what makes more sense to you intuitively. They both give you the same result. Here you're saying the future value equals the present value of 30,000 times the future value factor. And so here you're dividing the 150 by the 300. You get the factor. The factor is 5. So you go to the future value table, go down to the 21 years and across until you get to 5, and just get 8% there. Okay, so that's your unknown interest rates. So now, let's look at this one. If we have an unknown number of time periods, this guy will invest 10,000 today, earning 5% annual. How many years, how many ends does it take to get to 17,000? And so, again, these can be set up future or present, depending on what makes sense to you. So let's go across here, and if we do the present method, you're going to say, okay, the 10,000 equals the present value factor. We don't know the number of time periods, but we do know the interest rate, times the future value of 17. So the 17 future times the present value gets you back to 10. So you do the division, get the factor of 5882, and then you're going to go to the present value table, and you know the interest rate, so you go to the 5% column, you go down until you find something close to 0.5882, and it's 11 years, okay? Setting it up using the future value, you can just say, okay, so the future value of 17 equals 10,000, which is what we have today, times the future value factor, 5% unknown n. And so now you're dividing 17 by the 10, you get the factor, and you go to the 5% column until you find that factor, and you get to 11 years that way. So those, you'd have to do a few of those just to see, you know, just to get used to them. And so I think we'll move on next to see how these problems work, or how the tables work with annuities.